In this video, I'm going to give a brief overview of the lesson called Emma's average rate. This lesson is near the end of the sequence of lessons that were designed as part of the mELD project. The mathematical goal for this lesson is for students to identify the average rate of change in a distance time graph. From a language perspective, we want students to be able to describe the process that they used in order to identify and calculate the average rate of change, and to make generalizations about the multiplicative relationships, the speed, distance, time relationships that we've been studying throughout the unit. In order to support students' language production, this lesson includes multiple of the mathematical language routines, including collect and display, co-crafted questions, a co-constructed word wall, and a compare and connect routine. Finally, this lesson is aligned with the Common Core state standards, and in particular with the standards related to high school functions, interpreting functions, B6. That is, students calculate and interpret the average rate of change of a function, presented symbolically or as a table, over a specified interval. In this case, students are given a graph of that function, and they're asked to calculate the average rate of change, and then to generalize and actually produce a linear function that corresponds with that graph. This whole lesson will take place on the Desmos platform. So students will have papers where they can write down their answers if they want, and students will be working in pairs or individually using Desmos, which is where each of the slides appears, and also where all of the information is presented to students. We chose to use Desmos for this activity because Desmos allows students to try ideas out, to manipulate the representations, and to see a dynamically linked graph and equation and animation. Our design of the Desmos activity was inspired by the design principles that were used in the creation of activities such as SimCalc, which have shown in previous research to have very positive effects on developing and fostering student reasoning about rates of change. As usual, this activity starts with the routine, which one doesn't belong. And in this activity, we've given the students 4 piecewise functions to reason about. This is intentional because this will foreshadow the types of graphs that students are going to see in the Emma's average rates of change activity. We also gave the students a list of helpful words that they could use in their description of which one doesn't belong. We don't recommend that teachers define all of these terms at the beginning. Instead, we have found it very helpful for teachers to allow students to start using those words naturally as they try to explain which one doesn't belong and why. So the lesson starts with Emma's average rate, and it's a slide that shows an animation. On this animation, there are 2 characters. There's one in black, who is Emma, and one in red, who is average Emma. By the way, black and red were inspired by SDSU's colors. The students are asked, first thing, to play the animation and just observe what happens. And they're asked to see, what do you notice and what do you wonder? You might notice that when students play with this animation, they can actually create rather astounding graphs showing Emma going all sorts of directions, fast and slow, forward and backward, whatever way they want to go. But average Emma will always start in the same place and always end in the same place and always start at the same time and end at the same time as Emma. And this is one of the key things that we want students to notice as they're working through this activity. Students might naturally jump right into the question, I wonder how fast Emma's going. I wonder how fast average Emma's going. How do we make them start and stop in the same place at the same time? After the notice and wonder, it's very important to pause and to do what we call a collect and display. So here, we want to collect students' ideas. What do they notice and what do they wonder? And actually scribe what the students are saying up on the board. This gives the students the opportunity to see their language production reflected in a public display. At this point, it's not important to correct students' ideas or to tell them this is correct, this is wrong, or this is where we're going, this is not where we're going. The big idea here is to gather ideas and to think expansively. Slide 5 presents the very first challenge. On this slide, the students are given the animation again. The points are reset and now they're static, they can't move. And the students are asked to calculate the speed of average Emma that will make average Emma start at the same place and same time as Emma, and finish at the same place and same time as Emma. So the students will input a number that will represent the speed of average Emma. One small technical note, the students can't input a number with units. That's going to cause a problem in the Desmos activity. So students should present that with simply the number rather than the number with units. On slide 6, students explain what they did to calculate the rate of average Emma. On this slide, students will have to use some kind of language around the distance and the time, or the difference or the calculation that they did. You might notice that because this graph starts at 0, 0, students can simply use the ratio of y to x. However, we're going to find in a couple slides ahead that that will no longer work when we change that y-intercept, when Emma starts somewhere other than at 0. On slide 7, the teacher is asked to do a compare and connect routine. In this case, the teacher might either grab screenshots of individual students' work and put it up in a Desmos teacher mode, or if you're less comfortable with that, the teacher can simply again scribe students' responses. If you're using a dynamic whiteboard or simply using a static whiteboard, scribe what the students have said, and then compare and connect the methods that students used to calculate that rate that made average Emma start at the same place and time as Emma and finish at the same place. Next, on slide 8, students are going to generalize the relationship that they found in the first part of the activity. Now, however, the y-intercept has been shifted. So students are going to calculate the average rate of change, or the speed of average Emma. However, they need to account for the fact that Emma is not starting at 0, 0. In fact, she's starting at 0, 25. After students have the opportunity to work through slide number 8, on slide number 9, they're going to write up an explanation of what they did. So slide 8 is for exploring and trying ideas out, and then slide 9 is for formalizing and explaining a little more how you got to that final answer. Again, we have a slide on number 10, which is an opportunity for the teacher to collect ideas from the students and to compare and connect strategies that students might use to calculate the rate of change for average Emma. And in this case, we anticipate that many students are going to try to use simply the endpoint first and not be successful. This is worth highlighting. Why did that method not work? Then, at this point, is a good time to bring in the idea that the average rate of change is the total distance divided by the total time. And if Emma starts at 25 meters, then we need to subtract that 25 meters in order to find her total distance traveled, not the total distance as far as her final location. So this is distinguishing between the movement and the location. On the next few slides, starting on slide number 11, students are asked to write the equation for Emma. Now we're getting into more formalization. So the students are going to formalize the relationships that they observed in the first half of the activity. Here, students are going to use the y-intercept as their y-intercept in the equation, and they're going to use the slope as the rate of change of average Emma. If they're successful, they can type in that equation, and when they test it out, then average Emma will start in the same place as Emma, and at the same time, and finish in the same place and same time as Emma when they click submit. If the students try and are not successful, they can, of course, try new answers and keep trying out. Once again, we have this routine where students explore on one slide and then formally explain on the next slide. So slide 12 is an opportunity for the students to explain. And of course, you can see that the students can annotate the sketch and use the annotation tools in order to explain what they did. Once again, on slide 13, there's an opportunity to compare and connect strategies and to formalize some of the ideas that the students have brought out. So by sequencing different ways that students wrote that equation, we might be able to come up with a different way of expressing the general equation that relates average Emma's distance and time. Finally, there's a blank slide at the end where you as the teacher can write some notes or some discussion. And this might be a good opportunity, since we're near the end of the unit, to do some more formal note-taking, to have students really record in an organized way and consolidate some of the ideas that we've been playing with in this activity. Finally, on the exit slip, we're given a graph that shows Fernando, who walks at a non-constant rate one day, and then the students are asked to imagine that the next day he does the same walk, but this time at a constant rate. So they're asked to sketch the graph that would show Fernando moving at a constant rate of change, and then to calculate the rate of change of Fernando, the average rate of change, and finally to write that as an equation. So this exit slip mirrors the parts of today's lesson. And finally, we give the students an opportunity after the whole lesson is done to assess whether or not they feel like they've met the lesson objectives. That's the end of this webcast. I hope you found this useful, and I hope you enjoy using this activity with your students.